On this disc braked bicycle, the rear brake caliper failed. In this video I'll share with you what exactly failed in it, why this happened, and what I did about it to prevent it from ever happening again. Hopefully. Well, that's the plan. So this one is a cable actuated, that is mechanical brake caliper. Here is the cable running to it, where the cable mounts to this brake arm here, which operates a spring, and a single-sided brake piston is moving inside the caliper body here that exerts pressure on the brake pads that slow down the bicycle at the disc. Why this happened here at the rear and did not happen at the front is because of the position of the caliper. The front caliper has exactly the same age, exactly the same mileage, has been through exactly the same weather conditions as the rear, but this one is in much better condition. The reason for it is, again, the position of the rear brake caliper, where the frame is nearly horizontal, or so it's got a little incline to it, but whatever. Plus the caliper body itself has some more incline to it. But what caused the failure was due to corrosion, and we had 2 weeks of snow and road salting that caused it. Previously we had months, and before that years of rain, and it was working fine, but snow gets packed here, and when it's saturated with salt here at the Canada-US border, 49th parallel in the Pacific Northwest, the packed in snow just for this 2 weeks at sea level. We have lots of rain, and so the snow has been washed away since, but for the 2 weeks while we had snow, then all the salt saturated snow that made its way here corroded away successfully some critical moving components that need to be not seized up. So let me show you over here on the floor. I have here my storyboard happening, what I did and what went wrong. So on an intact one, and this is the front for intact, and this is going to be the rear one that failed. This is the end of the journey, and I'll show you how that looks like after all the butchering all the surgical procedure was done. So on an intact one, and just for rough reference, you can see the front forks here, and you can see the uneven length of studs coming out of the forks or fork leg. The brake caliper here is nearly vertical and clears snow and ice and salt with that snow with it. So the front one is in pretty good condition. I'll show you how it looks like. But what seized on the rear one was the outboard pad seized into the housing, as well as the brake pad seized to the outboard housing. Let me show you. So this outboard pad needs to be able to freely rotate. It's a threaded component, and the thread is on the outside, and the brake pads, which are let me find you the brake pads. Yeah, these are the 2 brake pads that came out from this one. They have a little bit of corrosion around the edges there, but that's okay. So normally the brake pad, okay, this is further in quite a bit. Let me just put this back here. There, the magnet there, the magnet holds it in place, and there's another magnet on the other side there. That's how this looks. And of course the brake rotor or brake disc is in between the 2 of them. So this is how they look in normal operation. And like I said, this outboard supporting block here is threaded and needs to be able to move freely once the lock screw or lock that locking screw there has been loosened. Then this should be able to come out like so. So there's the magnet in the middle, there's the other magnet in the brake piston, and the cable actuates this lever arm here, or lever, and then it moves the piston inside the caliper body, moving the brake pads, or one against the other, something like that. You get the idea. So this is how the intact or the used but fine looks like. With there is some evidence of some corrosion there, and it's been lubricated thoroughly with some oil since, because those holes, the tiny hole there and there, those also need to be clear and free of debris and deposits and everything. So this is the used, but it works and it's functional. So this outboard block sees to the caliper body. In this one, which I have removed since, and I'll show you the carnage, I mean the result of this surgical operation here. So first round was putting the proper tool into that one as well, and rotate tool a quarter turn. What resulted was rotation and a handful of aluminum, or aluminium in some markets, what is it, chippings or shavings. So this tool was spinning, and in this central recess here, where you can see that tool shaped surface there, and with the outboard block being seized in place, the tool that rotated stripped out the center of this outboard block. So that tool was useless from here on. So I said, not a problem, I'll probably grab a grinder and maybe cut a horizontal line through it and rotate it with a screwdriver, see what happens. That was the plan, but I said, before I do that, before I do permanently make a horizontal line in it, why don't I just try something easy and grab a needle nose pliers and see if I can rotate the seized component. That wasn't working, but I did gouge out the this center area there with this center rim here. And so that means it's yes, it's made out of aluminum or aluminium in some markets, and so it's fairly soft, and the serrated surface of the needle nose pliers left some marks in it. It's in this one, we'll get there. Next round, because I said, okay, this is slipping, so let's apply some more power. Let's have locking pliers on it, and I locked the pliers in place, rotated, and gouged it out even more. So then I said, okay, what needs to happen is, because obviously both are slipping off, is even more power. And why don't I hold the jaws of this in place with a second one? But that was kind of somewhat working, but because the needle nose jaws are somewhat tapered, it was kind of more like it working somewhat, but not really. And then I rotated the needle nose pliers this way, where the jaws don't move sideways like on a pair of scissors, so stay in place. Well, this was gripping the center part of this outboard plug way better, but as a result of all this force and pressure, it collapsed the rim, this inner rim, it collapsed it in and broke out a chunk from it. So I said, not a problem, I'm gonna get an Allen key or hex key and put it in the middle, like so, not this one, just a skinny one, not a socket one, and that way the rim can't possibly collapse in anymore, and grab it again at the center, a new spot somewhere, and try again. But it wasn't working, it was just slipping, and it was not really working out, so I gouged out the aluminum even more. Then I said, okay, done with all of these locking and pliers, whatever, I need more leverage. That center feature, grabbing it and trying to rotate it by the center feature is not enough. I don't know if I mentioned it, this was soaking overnight in penetrating oil, not this, the seized one, and but that's the penetrating oil before any of this was attempted. So that overnight, I don't know, 8-10 hours, something like that. So then I said, I'm gonna need an idea that I got from the this is an angle grinder, and you see those two holes that that provide this clamping force on this lock nut there, and with the adjustment or with the proper tool, this is how this works. So I said, why don't I try to duplicate it and drill two holes in it about 180 degrees apart, and find two of the thickest nails in 5 minutes that I can come up with, and drill two holes and see if I can put a wrench on it and produce rotation. That worked. As a result, this is how the finished product looks like. It's all ugly, chewed up, gouged out. Part of it is broken out here, but with these, and two different size of holes are in it now, but with these two nails in place and with the crescent wrench or adjustable spanner, whatever, on it, this could be rotated after having soaked in oil or lubricant for overnight. So then this came out with some grunt. The thread on it is still corroded or damaged, or yeah, it's just corroded, that kind of damage. So not physically otherwise damaged, just some corrosion there. And the inside, just for a contrast, looks like this. It's been lubricated, as well as you might see some scraping or scratching marks since, and those two tiny black holes there and there, they were all clogged up, so everything had to be cleaned out with a tiny drill bit that I could put in and just remove the dirt from it and clean the caked on thick layer of deposit that needed a woodworking chisel, a sharp one and a skinny one. So something for a skinny chisel for like mortise and tenon work. So just for contrast, here is the intact for a visual used but intact versus very used and very corroded and seized up. So there, so this is the front one on the left side, and the other one is just more corroded plus scratched. So this is after removing all the cruddy stuff from it with a woodworking chisel. This needed none of that. This was okay-ish, because of its mounting position, the brake dust that's being generated as the brake pads wear away, I'm not saying entirely self-cleaning, but a lot more self-cleaning than this one that's mounted on nearly horizontal part of the frame. Even though this is on somewhat of an incline, it's not really, sorry, it's mounted this way, it's not really self-cleaning. So this happens to be Hayes CS Expert, that's the make and model, but that's not the problem. The problem is its position, that it's prone to accumulating salt and snow on it. Rain wasn't really corroding, because before this snowy event they were both looking identical and they were both identically adjustable, not a problem. And obviously, so this is going to be assembled, because this is not it's used but it's not destroyed. The brake pad, you can see from this corrosion pattern here that the brake pad is supported along its edge here and at the center, like so. So that's why I drilled the holes where I did drill the holes, and it lies flat and just needs some generous amount of anti-seize compound on the thread or grease, as well as here. Not oil, because the oil will eventually run down and will migrate and make its way to the brake pad surface, where there shouldn't be any grease or oil or anything. So something that stays in place here and here on these surfaces. This can be reassembled, because this part as is unavailable as a as a single part. Now a new caliper like this could be as low as $40 or 40 euros or whatever, but yeah, I don't have that kind of money, plus it's Sunday and I need to get it done and need to be going by Monday morning at 7 AM, so I don't have that time, or I don't have the components to anything else to do other than repair and reassemble, or in this case this is repaired as is, made functional. So I have confidence in it. Now it's ventilated, you know, if you want to push it. So because it didn't compromise the rim that holds the brake pad on the inside, it's fine. Just needs to be put together with some TLC and some anti-seize compound or grease. So that's how this miserable story here unfolds, and that's what I tried, and that's the version that worked. So if you omit and skip all of these, you'll save yourself, I don't know, 4 hours. And if the same happens to you, you may not be so drastic, but if it's seized up, it's seized up. Plus, regular maintenance and regular removal and reapplying some grease on the thread would probably go a long way in preventing this whole thing in the first place.